The construction industry shapes our world. From the buildings that we call home, to our workplaces, the roads and railway lines that we travel on, the infrastructure that enables transportation and generates our power, and the environments where we nurture, the construction sector has a fundamental impact on every aspect of our society. For centuries, the way we build our world has remained largely unchanged. We use many of the same materials and processes. We still build a prototype structure in its final location, on a site that is always unique, at the mercy of our surroundings and the elements. Though the concept of developing structures away from their sites is nothing new, our changing cultures, rapidly expanding population, shifting workforce demographics and ever more technological world are now heralding a new dawn for the concept of offsite techniques and seeing them take a decided shift toward the world of manufacturing.
The challenges we have as an industry now are different and unprecedented. We have headlines that suggest we're not able to deliver what we said we were going to deliver.
There's a whole load of expertise in manufacturing and automation and other sectors that we could never get our hands on because we were never quite close enough to them. And it feels like the pace at which this will move could be incredibly quick.
If we drive too much in terms of cookie-cutter approach to design, etc., I think we may end up not realising the benefits and going back to more traditional methods because people need to want it. It can't be forced on people.
The move towards a different model of delivery for me is crucial. It's crucial if businesses are going to survive in terms of their financial stability. It's also the key to growing margins.
So, could these approaches truly transform construction? Could they improve quality, cut costs and raise productivity, while helping us tackle issues like the lack of skills coming into the sector and the housing crises facing many nations? And why, if the benefits are so compelling, have we not seen widespread uptake to date? This is how construction could soon become manufacturing. Unlike almost every other sector that delivers physical products to its customers and end users, construction creates unique products in unique outdoor locations every time it delivers. While some buildings and structures can be constructed repetitively using the same designs and materials, such as restaurants, hotels, or prisons, no two sites are identical. As such, the industry is in effect always delivering prototype products for its customers, while striving to achieve quality, efficiency, and a safe working environment, without disrupting surrounding communities. Approaching the design and construction process with an off-site mindset that is much closer to the concept of manufacturing enables work to be moved away from the unique challenges of each job site and into controlled conditions. Here, economies of scale can be achieved through production lines that embrace automation and use standardized elements. By having teams focused on producing specific aspects of a building component repeatedly under the same conditions, productivity can be increased and quality can be substantially improved, reducing the number of defects in the completed building. There is also the benefit of reducing time spent on site, where the costs of providing temporary power, accommodation and facilities can quickly add up, and where the potential for disruption is high. While some of these time and cost savings are of course offset or occasionally even cancelled out by other elements of the process, the benefits of moving away from the site environment are still compelling. Quite aside from the advantages in delivery, off-site approaches appear to provide attractive solutions to a number of the challenges currently facing our wider society. These techniques could allow housing to be delivered more rapidly in high-density urban areas, helping to tackle the housing crises currently facing many developed nations. They could also enable the fast construction of infrastructure projects, enabling new and emerging communities to grow. An underlying contributor to the housing crisis currently facing the UK is a lack of skilled operatives entering the construction workforce. Offsite approaches could help to address that by reducing the demand for labour capable of constructing homes with traditional methods. The extent to which works are taken away from construction sites varies significantly. At one end of the spectrum, volumetric solutions create entire enclosed spaces in a factory and then deliver those to site for installation or assembly with other similar elements. Some buildings may incorporate a degree of volumetric construction in the form of bathroom pods or plant spaces. Conversely, non-volumetric systems are large elements of a building or structure that are prefabricated before being brought to site. Panelised systems such as cross-laminated timber or structurally insulated panel systems, known as SIPs, fall into this category, as do unitised facades and large precast concrete elements. Finally, component-based approaches take the concepts to a far more granular level, effectively creating a kit of parts and drawing on a series of predetermined items that can be produced, delivered to site, installed, operated and maintained with ease. To understand more, I spoke to industry expert Mark Farmer, founder and chief executive of Cast Consultancy and author of Modernise or Die, a landmark report published in 2016.
What does offsite mean to you?
It's an umbrella term, so offsite construction essentially is an umbrella term and it means a whole lot of different things, but in essence it's talking about transferring activities, construction activities that would have happened at the final work phase on a construction site. It's talking about moving those somewhere else, and that somewhere else might be a remote factory hundreds of miles away. It might be a consolidation centre close to the site, or actually in some instances might mean that some form of assembly or pre-assembly is being done actually on the site.
What's the benefit of doing that?
One of the problems we have in the construction industry is inherent in the way that we deliver, because we're not building cars and aeroplanes. We're building buildings that are in locations, and invariably we tend to do that building in situ at the final work phase.
It's almost a prototype every time, isn't it?
Yeah. So everything we do is essentially bespoke. Very little harnessing of repetition, standardization, commonality. Architects will respond to a brief and design something from first principles, and then we build that. And actually, if you're doing it right with the right process and use of technology, then actually you start to address the issue, which is the real bugbear for construction, which is productivity. And I think the other thing is the term off-site construction is perhaps a particular hobby horse of mine that perhaps we should be better using the term off-site manufacturing.
Around the world, numerous countries, governments, organisations and suppliers have embraced off-site approaches. In Singapore, the country's construction regulator has introduced a mandatory target that 65% of high-rise building superstructures should use prefabricated, pre-finished modular construction. The project team working on the Crowne Plaza hotel extension at Singapore's Changi airport claimed that embracing this approach reduced the number of operatives on site by 40% and brought the time to construct a floor down from 2 to 4 weeks to just 4 days. The country's emerging Canberra Drive development, consisting of 8 mid-rise blocks, is reportedly the world's largest modular construction project. In Australia, Hickory Group used prefabricated elements to construct Melbourne's 60-storey Collins House, improving quality, reducing programme duration, and overcoming the logistical challenges presented by the 12.5-metre wide site. Hickory adopted similar approaches on the city's La Trobe Tower. In the United States, Factory OS recognised the benefits of embracing a manufacturing mindset and market their volumetric solution as the answer to housing demand and the lack of skilled workers entering the workforce. In a similar vein, the slickly presented Katerra are taking long-established panelised and component-based construction approaches, but delivering them through a business that they claim is highly technology orientated, deliberately employing expertise from beyond the construction sector to drive innovation. Offsite approaches have also been employed across the UK market for several decades. Indeed, the concept first came to prominence after the Second World War, when the country rebuilt large portions of its building stock. Particularly notable projects in recent times include London's 23-storey Creekside Wharf, which is formed from volumetric modular units, and the vast Alder Hospital, which extensively embraced off-site fabrication techniques. On the horizon, off-site approaches are being explored at some of the UK's most significant projects, including the new nuclear power station at Hinkley Point and Heathrow Airport's third runway. On the surface, the UK is seemingly well served by firms with off-site capabilities. At the volumetric end of the spectrum, established businesses such as McAvoy, Elliott, Caledonian, Elements Europe and others support the delivery of numerous projects across the country. Other, more specialised volumetric providers have found niches in areas where factory-controlled production is almost essential. Connect to Cleanrooms, for example, create modular cleanrooms that meet infection control standards and service a number of sectors. Meanwhile, in the non-volumetric arena, businesses like Innovare Systems produce panelised building elements that can serve a wide variety of building typologies across a spectrum of different sites. At general contractor level, notable forward thinkers include Kier Group, who have actively embraced off-site concepts on a number of projects, and Laing O'Rourke, who claim that their Explore Industrial Park is the most automated construction products facility in Europe. While many of these businesses have served the UK industry for several decades, it is only recently that excitement around the potential to mass manufacture buildings, and in particular homes, has increased, largely as the country's population has steadily grown, as the housing crisis has begun to bite, as the build-to-rent market has risen, and as the construction sector begins to feel the effects of a severe skill shortage. Successfully answering these challenges with a mass production solution is a seemingly alluring prize that has driven the creation of several new ventures and investment decisions. Housing associations Swan have opened a modular factory in Basildon, while Berkley Homes have begun developing modular solutions at their factory in Kent, and Ilke Homes have invested in a factory in Harrogate. Underlining the appeal, financial services giant Legal & General are now entering the market with their modular homes offering, attempting to address the country's housing crisis by constructing a vast factory near Leeds. Though currently only part utilised, the facility is expected to steadily scale up production in the coming years. However, despite this surge in interest, last year just 1% of new homes in the UK were manufactured off-site. If the benefits are so compelling, and the industry is seemingly almost overserved by suppliers, why are we not seeing a widespread shift towards an off-site manufacturing mindset in UK construction, and in particular in the house building sector? For decades, a number of factors have held us back. Firstly, at a cultural level, the construction industry is notoriously resistant to change, and the methods used to construct many of today's buildings and infrastructure have remained fundamentally unchanged for centuries. If that cultural barrier weren't significant enough, we live in a society where standardization is celebrated and even desired in areas, but where the vast majority of consumers seek a bespoke building or home. This is in notable contrast to some other cultures around the world, where off-site manufacturing techniques and modular homes have thrived. In the UK, many consumers perceive the term off-site to mean low-quality, boxy-looking modular buildings or homes that lack character or architectural appeal. And the country's Grenfell Tower disaster has hardened views around the importance of building quality. These preconceptions are reinforced by mortgage lenders and insurance firms, who have been wary of backing such schemes in the past, dissuading consumers and developers alike. Several examples of attractive modular architecture have emerged over the years, only to fall from favour again as trends progress. Within the industry, some project teams have experienced low-quality off-site solutions or discovered that cost savings are merely offset elsewhere. Others lament the transporting of air that some volumetric solutions require, or that any value achieved is not always passed on in a sector where margins are infamously low. The use of off-the-shelf, customizable volumetric solutions has also proven difficult to apply at scale across the wide variety of physical sites that the construction industry contends with. Conversely, panelized solutions have performed better, able to adapt to different footprints and site constraints, blending the benefits of standardization with a sufficient degree of adaptability. The extent to which true manufacturing approaches have been adopted across the UK sector is also highly varied. While many use the terminology, the degree of automation, efficiency and scale within UK off-site production facilities is on a broad spectrum. In addition to these barriers, driving ultimate value from off-site techniques relies on planning and designing for such an approach from the outset, a challenging task in an industry where contracts and procurement routes are geared towards the engagement of suppliers in the later stages of development.
What is stopping the construction sector taking that manufacturing approach?
So one of the biggest barriers to the growth of the off-site sector has been the basic delivery model that is adopted in construction at the moment, and the basic environment, the economic environment that construction operates in as well. So what we've moved to in the industry is a highly flexible model where there's very little willingness to invest in fixed costs. So plant, machinery, overheads. There's very little willingness to employ directly, hence the proliferation of subcontracting over the last 30 years. So actually what you have to do if you want to move to an off-site manufactured-led approach, you have to invest. So there's costs of setting up an establishment. Depending on what scale you want to do it, there's invariably the cost of either leasing or building a facility. You have to equip it, which is usually the primary cost of machinery. And then you have to hold a payroll because you can't really do off-site manufacturing with a transient workforce. You need to employ people, you need to train them.
I mean, in terms of the people that have made the investment, where have you seen the kind of best practice so far in terms of people that are taking the leap and going down that road?
The common theme for me are businesses that have put technology front and centre in their propositions. So they're coming forward with a manufacturing approach, and invariably in the volumetric world that means a factory as well, and sometimes quite a large factory with lots of investment. But there is a real difference between, as going back to the difference between off-site construction and off-site manufacturing. Building in a shed, I don't believe is scalable for the future. Manufacturing in a factory is the future, and the manufacturing for me has to be digitally enabled. And what we're now seeing, and it's only really in the last 2 or 3 years it's starting to really become apparent, is that the pace of change in technology is now fundamentally transforming how manufacturing can be done. And that's impacting business models, it's impacting the ability to create digital platforms that are much more scalable in terms of manufacturing output. You create a digital design front end to your proposition that then feeds through to digital manufacturing machinery in your factory. It's all hardwired, it's all parametrically controlled. And then you create something that I believe is a lot more scalable.
It's technology that's going to help, you think, make that step change, make that difference?
I think so. It's a personal opinion, but the evidence points I see when I go around the industry and talk to people, and some of the sort of real things coming over the horizon, which are really, really interesting and exciting, all have technology placed at their heart, and not as an afterthought. Actually, if anything, they start with the technology and then work out what the manufacturing is that supports the technology. I think sometimes you could retrofit it and it doesn't quite work.
Keen to learn more about how these challenges play out on the ground and to see an off-site facility up close, I went to meet Pete Blunt, who runs Innovare, a business specialising in the manufacture of structurally insulated panel systems in Coventry.
Pete, great to see you. Thanks for having us. So, I mean, what is Innovare? What do you guys do?
So Innovare, offsite construction specialist. So we do the design, manufacture and installation of large format components direct to site to drive speed and quality of offsite manufacture, but also because everything we do is bespoke, it provides the flexibility to create different forms and shapes, etc., to meet with the local vernacular or architectural requirements.
So when people say SIPs panels, what do they mean?
A SIP is a structurally insulated panel. What happens is that you have two boards, bond them together to a structural insulation core, and that gives the benefit of both strength and thermal performance.
I guess there's quite a lot of adaptability there as compared to like volumetric or bigger offsite.
The reason why we do large format panels rather than 3D volumetric units is it gives the flexibility on site as well as the speed and quality aspects to it as well. So we take the pre-kitted elements through on these trolleys, and then each individual panel is bespoke to its particular application in the building.
So this here is one of the panels coming together right in front of us.
Yeah, so these are the basic carcasses that are assembled offline, and basically all the work is done within the panels. So where, as you can see here, every individual panel is bespoke. So we put the openings, the windows, be it doors, and also any structural requirements, so lintels, key element posts within the panel. Yeah. And so what that means is that therefore we can do all the hard work in the panel, and therefore it's a lot easier to install on site. The strength comes from the actual insulation itself bonded to the boards either side to stop the boards from crumbling. The additional timbers just provide additional support in key element areas.
Much of Innovare's design planning process and the way in which panels and components are tagged and tracked through the factory is automated, with digital technologies playing a key role. So this is where the bonding takes place, right here in this machine behind us.
Yeah, so essentially the carcass has been loaded onto the bottom board, which had adhesive applied to it. It's now been applied to the top board.
So after the glue's been applied and the board's been applied, is there a compression that goes with that?
Yeah, so then it goes into the press for about 15 minutes at that point. Literally, when it's in that press for 15 minutes after that, then that's bonded and solid, and you can't pull that off. And that's the great thing about the adhesive, but also you've got to therefore make sure you look after it properly as well.
So after that compression, the panel's then into this zone here?
Yeah, so after the panel's been pressed and consolidated, what they do is they tidy up the panel, and sometimes we need to put additional boarding on it in terms of fireboard or anything else like that for additional performance. Again, trying to simplify what happens on site as much as possible, and they flip it and do their QA checks both sides of the panel.
I guess the beauty of here is you're indoors, it's warm, it's dry, it's much more controlled.
Yeah, it gives us the opportunity to really standardise the operation. So whilst we're doing bespoke panels every single time, we can standardise the operation in terms of what we do and how we do it, which means therefore we get that consistency and quality coming through the product.
Yeah, so a lot of those challenges you get on site, and you just say every construction site can be different, every site in the world is different, a lot of that is taken away, and you're bringing more towards that manufacturing mindset.
Very much so, and I think the key difference from this side is about the fact that with everything being bespoke, we get the flexibility of the end product, but we get the quality and the speed from a manufactured product. Each of the panels will come through here, they'll get flipped over, and what happens is they put the membrane on top, and this is for either from a weathering perspective or even during construction fire performance perspective to ensure that they've got the right finish on it. The other side to consider is our stacking sequence is absolutely critical to it, so it's making sure that stacking sequence, which has been delivered all the way through the process, is to make sure the first panel off is the first panel to be installed. So the other benefit from an off-site perspective is you can start reducing the number of people on site, but also improve the health and safety aspect. So these one-way straps mean that we can be loaded up, because all of these are crane installed, they can be loaded up and then it's simple cutaway, so therefore you haven't got people working at height and you haven't got people having to do additional things on site to the consistency and quality that we need.
So I know it's a bit of a difficult question, but from start to finish, how long does it take a panel to go through the factory?
The way we set it up is you're probably looking at a couple of hours, and the reason is a couple of hours.
Wow.
And the thing is actually what we try and do, we've got, for the external walls we just talked through, we look to get a panel off every 30 minutes at the moment off each line, so it's 2 panels every 30 minutes, and they can be up to 6 metres by 2.7, so So a full elevation of a house, or you get 3 panels into an elevation of a school within that. So that gives that drives that speed aspect. The issue is in terms of some of the other elements, again, it's just size, speed and flexibility around that.
Innovare's geographic positioning in the very centre of the UK is strategic, putting it a serviceable distance from the majority of its existing and potential customer base.
Completed panels are loaded up in the right order and out the store.
We try and hold as minimal stock in terms of finished goods as possible, and then they're loaded onto the wagon in sequence to make sure that therefore it's as easy as possible for the guys to get to it on site.
So do you think the UK construction industry embracing off-site in a wider way would make a difference overall in terms of quality of builds, efficiency of projects, that sort of thing? Does the industry need to be going down the off-site road?
I think the industry needs to improve productivity, full stop, and also on the advent of some of the changes in regulations, etc., that drive for quality and assurance is absolutely critical. Off-site is one of those solutions that could provide some of that answer, but it's not the overall answer. A lot of it is down to cultural acceptance of that drive for quality and consistency through the process.
What do you think it is that will make the difference in terms of getting more widespread uptake? What needs to happen, do you think?
Lots of people talk about economy of scale in terms of more workload through it. For me, fundamentally, from a manufacturing perspective, not even just a manufacturer, but any business model is about the economies of flow, and actual consistency of workload and forward visibility of pipeline is critical when you have a manufacturing facility of any shape or size. I think the rate of growth of off-site and the level of uptake, the government getting involved in terms of driving that, shows massive opportunity for the off-site sector. I think there were some studies done that off-site fabrication has a cycle, and it's a 30-year cycle. So unless we get it right now, we've got 30 years to wait. So the opportunity is now, and if we grab it and really drive those benefits that it delivers in terms of that quality, that speed, but also the ability to create some amazing spaces, then it can be here to stay. If we drive too much in terms of cookie cutter approach to design, etc., I think we may end up not realising the benefits and going back to more traditional methods, because people need to want it. It can't be forced on people.
So it's almost like flexibility within a range. In the automotive industry, they can have what they want, but it's from a set range of cars and in a certain number of colours, giving people choice from a standard set of elements.
The benefits and advents of digitisation, you can have information quicker to be able to make better choices. So it's not about saying no to everything. It's saying if you want that or you need that, then you can have it, but it comes at a cost. So people aren't expecting everything bespoke for the same price, but they can have what they want if they're willing to pay for it. And the automotive do that in a great way, because they standardise that. They standardise what those options can have, but you also have choice because you have got lots of different automotive manufacturers to go to. So on one end you can go to a £250,000 Bugatti, or you can buy a runaround for £6-7 grand. You've got that choice, but within that you've got choice in terms of specification of the bits. And for us, we've got to learn from that rather than just saying it's a Volkswagen Golf and that's it.
So that was Innovare. I guess the big thing that's impressed me about that is the adaptability and the versatility that they've got with their product. Here they can make a panel of pretty much any shape or size with window cutouts built in, with door cutouts built in, that can be applied to that huge variety of different types of project we have in construction, and the unique nature of the design pretty much of every building and the unique demands of each site that we build on. What really struck me is the way they're kind of taking the best of both worlds. They're bringing a lot of the work away from site as much as possible. They're coming out of the rain, the mud, the wind, the water, all those variables that you can't control, and they're trying to step into that world of manufacturing and the factory type approach, where you have a super controlled process that's continually honed and improved over time, but with the adaptability and the versatility that's needed in the construction industry. I guess the impressive thing here, there's this huge factory, it's buzzing, it's a military operation, they're a company that's there, that's ready to go, but as Pete was saying, there's there's just that demand that's needed in the industry, that there's that appetite, that changing culture to get us to back this kind of stuff. And it feels like, going away from volumetric and the big kind of traditional modular companies, this gives the industry the versatility it craves, whilst standardising at the same time and getting some of the efficiencies and the economies of scale that come with factory manufacture. It's been a really awesome experience. I'm sort of seeing now, with that more component-based approach, where is this headed and where's it going next? I just want to pick up on this theme of standardization, because obviously other industries have standardized, and that's kind of what's driven their success. So the likes of IKEA, which we touched on earlier, they do manufacture lots of different things, but they're sort of available from a catalogue, and you can have them in a set of colours, but that's more or less the restriction. It's more or less the same with cars as well. So there's the base model, but you can have extras and you can change the colour, but that's kind of it. Whereas with buildings, there's this kind of culture that we want a bit more bespoke, more of a prototype approach, and that's kind of where it feels to me that's kind of where the challenge has been. But really, with components and the manufacturing approach, that's almost the way around that. It kind of draws on the benefits of manufacturing and standardization, but with that degree of flexibility.
Yeah, and I think what you're touching on there is a real opportunity that again can be enabled through technology. So the idea of platforms, common platforms of design componentry or sub-assemblies, is something that is absolutely the norm in automotive. So if you take any of the large car manufacturers, they will have various models, but what you don't realise is that within that range of models, probably 40% of the components that are being used, particularly in the back of the drivetrain going through to the dashboard, that you don't necessarily see, they're functional things, are common. And that ability to build off a common platform of components and assemblies, and then customise what it ends up looking like in the chassis of the building, in the building terms that will be the cladding and the shape and some of the internal finishes. We just haven't really managed to grasp that in construction. Quite recently, we've had an announcement from the central government that they're going to consult on a whole different way of building their social and physical infrastructure programs, so schools, hospitals, prisons, their defence assets, their transportation assets. They're thinking about platform-based design delivery. And what that essentially means is that rather than volumetrically pre-assembling, they will break their build programs into an inventory of common components. What they're going to do is actually establish that as a client. And the critical thing here is for this to work, it has to be client driven. You have to set out your Lego set, if you like, of things that you want to build from, and then give it. It has to be demand led, because actually, if you're, going back to where the existing off-site industry is at the moment, they're all coming forward with individual responses. They're not demand led. They're the manufacturer's viewpoint on what they think the market wants. At the moment, the manufacturing sector is leading the clients, and actually, I think we need to get a bit of balance where the clients procure intelligently, procure in bulk, but retain the ability to customise what they're building, so you don't have homogeneous buildings that all look the same, cookie cutter, because that won't be acceptable. No. The planners won't accept that, architects won't accept that. No,
that's the thing. We haven't, as I was saying earlier, we live in this world where we accept standardisation. We actually love standardisation in some things, but when it comes to buildings, everyone wants that unique.
And it's a really important point, Fred, because if we force standardisation to the extent it affects the architecture and the aesthetic and the planning context, it will never happen. Because there's so many detractors of wanting to see off-site disappear down the road, vested interest, whatever you want to term it, but part of that will be an architectural lobby that perceives off-site to be poor quality. And one of the challenges, if the off-site sector and the construction as manufacturing agenda is going to grow, it has to technically address that challenge and be able to prove that buildings that have more manufactured content, you can look at and think, I can't tell. That Absolutely. Could be a bespoke building. Absolutely. And that's going to be a challenge that I think, again, technology will be the element of enablement there.
The key to unlocking the ultimate value promised by off-site manufacturing approaches could lie in these component-based systems. Solutions that break buildings and structures down to their simplest ingredients and build from a predetermined kit of parts, sustainably sourced from localized supply chains. Such systems could give us the benefits of standardization while providing a sufficient degree of adaptability to meet site and planning constraints. The UK is in fact leading the world in this area. To learn more, I visited Bryden Wood's Jamie Johnston at the Construction Platforms Research Centre.
Jamie, hi.
Hi, Fred. Right, welcome to the Construction Platforms Research Centre.
Thanks for having me.
Should we have a look inside?
Absolutely.
Let's go. So this is our testing facility. So Bryden Wood was set up specifically to look at how manufacturing does the things it does. Better productivity, better quality, better features and things year on year, while construction fundamentally hasn't changed for hundreds of years. So we're trying to develop construction systems that can be deployed quickly, safely, with high productivity at scale. So think IKEA for construction. We're trying to develop the IKEA kit of parts here. To do that, we need to try lots of things. We need to fail at lots of things. We need to perfect things in a sort of safe environment. So this is our kind of sandpit where we try things out before they're ready to then be deployed at scale on live sites.
Having analysed the array of buildings constructed by the UK government over recent years, from prisons and military accommodation to hospitals and schools, Bryden Wood and their partners have identified the core components found in almost every structure. From there, they've explored how best to manufacture those components using high levels of automation to drive quality and productivity. Concurrently, their teams have also identified building components that could be produced by low-skilled workers, helping to overcome the severe lack of skilled operatives entering the workforce. Trialling this with the UK's Ministry of Justice proved highly successful, with prisoners able to construct a complete two-storey block after limited training. The trial significantly improved morale among inmates and saw several prisoners contribute ideas as they engaged with the project.
So this is what we call a super block. So this is part of the facade system that we developed for Platform 1 for the Ministry of Justice. So this is an individual unit. These would then be stacked 10 high to make what's called a mega block, and then that gets lifted into position, and it's the facade system of the finished building.
So what are these super blocks made up of?
So they were designed to use pre-existing, easily available commodity products. So this is a thing called gravel boards. So commodity material made by the mile. We actually had our own moulds made specifically for the MOJ project, which is explained. Rigid fireproof insulation, so that keeps the two gravel boards apart. Band straps, stainless steel band straps, so exactly the kind of thing that you see on pallets.
Yeah.
Brick slips, because the planners liked brick, it weathers well and it's quite a personable, tactile material. And there would have been mineral wool insulation inside.
So we've spoken a lot about how simple these are to put together, and they look really simple to put together. It can be done by low-skilled workers.
It can.
Obviously, you're one of the global thought leaders on this area, and I'm sort of a minor YouTube star, but we are technically low-skilled workers when it comes to this. So should we have a go, you and I, putting something together?
Absolutely. Let's have a go.
Okay, so this is literally an unbuilt super block.
Yeah, so this is the gravel board with the brick slips that we've just seen on that table. So this is the starting point. So you get one of these lying down.
Jamie and I are going to each have a go at putting a super block together now, and we're going to compare at the end whose super block basically looks better than the others. Let's see. So start with this.
Okay, so you start with this, then you have your pre-cut insulation blocks. Second block goes on top, lines up. Same again on the other side. Drop that in. So then the next gravel board sits on top. Strips go in now.
Okay.
Band straps.
These are just fed through grooves in the gravel boards.
Yeah. So again, this is just industry standard basic equipment.
These literally just look like what you see on pallets.
Yeah, it's exactly the same.
Right. You notice that Jamie's a lot more slick at this than I am, which is a giveaway that he's been secretly practicing. How long would it take to put a super block together?
So we were down to 3.5 minutes. Couldn't get much below 3.5 minutes while keeping quality, but actually 3.5 minutes to make one of these is, you know, they were churning out significant numbers with a handful of people.
And how long would a super block tend to last for?
Everything was designed for 60-year lifespan, so same as traditional construction. But again, concrete, inert material, concrete, brick slip, stainless steel. There's nothing in there which is has a particular lifespan problem.
Remarkably quick to pick up, isn't it? It's not complicated. It's really, really straightforward.
And quite satisfying.
Yeah,
isn't it?
It is very satisfying. There you go. So I mean, they look identical, but if you think one super block is more super than the other, do let us know in the comments below. So what have we got here?
So this is our prototype of Platform 3. So this is our 9 metre by 10.5 metre grid platform that we're developing for large span offices. So this is an animation that we put together to show our first thoughts about what automated construction would look like. So this is predicated on Platform 3, which is our office platform. So it's designed to make a 10.5 by 9 metre grid. So what you see is the long span elements going in here. What's coming in here is then the spanning elements. This is a known product. Manufacturing is very good at bringing work in progress to the point of use. So this is showing a rig that's bringing the work in progress beams. They could be lifted up into position with, again, known technology, a thing called reach stackers. The next thing we'd have is reusable bracing. So on the top left, you can see the bracing that we developed up in Platform 2. This is lightweight, aluminium, reusable, very accurate, self-locating. What this does is hold the beams, firstly, so they're very, very straight and accurate. It also means that we can very quickly, as soon as the concrete's ready, we can go and walk on top of it because some of the load is taken through that bracing. So we like to bring in these shutters with the rebar already on top of them, rather than have precast heavy units made somewhere, brought to site and craned in. We can achieve the quality of precast by having very, very accurate shutters, which again, because it's a part of a system, we can do that, lift it into place, and then we pour the concrete, or we place the concrete on site, so we get precast quality but without the downside of precast. Again, there's existing technology that would allow you to tie the rebar together, very automated, very productive, without people and the health and safety risk of walking on top of the concrete. So then, rather than pour the concrete on from the top, we had a plan to pump the concrete in from underneath. And actually, that's exactly how jet engines are fueled, so that technology exists. We've since gone and bought some of the connectors. We've tried this and it works quite well, actually. So you pour the concrete from beneath. We then guessed that you could get a piece of equipment that would, again, automated level the slab. Turns out that someone makes that. We then guessed you could get robot power floaters. Someone makes that. So this is all technology that exists but hasn't been placed together. If you could just corral all of this stuff, you could suddenly move things forward. So then strike the formwork. MEP units then get lifted up, again, because the superstructure is super accurate. That works really nicely. The next thing we've started to do is, now we're into that kind of level of granularity, is use discrete event simulation to model these processes. So that's time-based modelling that we use to optimise manufacturing processes for GlaxoSmithKline, for instance. We can work lots of virtual shifts and work out what's the optimum number of people, equipment, machines, what's the takt time we're working to, and we can really fine-tune this until we get maximum productivity on site. Our guess is that we could deliver buildings potentially 50% quicker with 75% fewer people. And of course, once you get the superstructure up and it's incredibly accurate, it unlocks a load of existing systems. So there's already very good systems for installing cladding accurately, MEP systems, etc. So we spend quite a lot of time on the superstructure, because once you get that right, it unlocks productivity in every other work stream, and suddenly you start to get a very cohesive system. This is effectively permanent shuttering for what will be a concrete beam. So we have here, you can see one with the reinforcing bar in. As you saw in the animation, what we want to do is bring a whole stack of these together and then use a reach stacker to lift it up into position. So this is our really early prototype of that stillage, that rig. This is the real start of that process of taking something from the animation, trying it out, bringing it to life and seeing how it goes.
Yeah, and I guess testing it here in this space is much better to learn that way than when you're into your first project.
Yeah, so typically what we'll do, we'll have a go at it here with things like the timber version. Once we've ironed out most of the problems, we'll then try it outside at scale. Again, there'll be a load of learning that comes out of that, and then that moves us into the next stage before we start to deploy on site. So we wouldn't ever do a thing on site that we haven't tested a bunch of times, ironed out all the things, written all the method statements, and know exactly how to do it quickly and safely.
While off-site approaches have been present but not widely adopted across the UK industry to date, the pressures of our expanding population, housing crisis, and severe industry skills shortage, combined with significant advancements in technology, appear to be rapidly advancing the market. The broad spectrum of solutions available, from volumetric systems to SIPs, component manufacture, and even 3D printing, all seemingly have their place. While customizable volumetric solutions are perfect for a range of requirements, the key to widespread uptake in every area of construction could lie in panelized systems and component-based platforms, solutions that offer higher degrees of adaptability while retaining the benefits of standardization and manufacturing. Making our industry more accessible, broadening the talent pool, and enabling us to build in a faster, higher quality, and more productive way, while also meeting our deep-rooted cultural desire for unique buildings and the challenges that each site presents, is a tall order. But from these tough parameters, it appears that much of the innovation and advancements now being made could be about to fundamentally disrupt the way we choose, design, construct, and even think about the built world that surrounds us. If you enjoyed this video and would like to get more from the definitive video channel for construction, subscribe to the B1M.